Hi, I'm Kelly. I'm here with Team 1778 Chill Out at the PNW Glacier Peak District event. They've been a consistent coral scoring machine and can solo the coral RP without co-op. I'm here with Eli, Simon, and Apollo, and we're going to be talking about the design considerations that went into the intake and the elevator, and some of the software and vision that goes behind all of it. All that and more on Behind the Bumpers. All right, take it away, Eli.
All right, so as Kelly mentioned, we're going to be talking about some of the design considerations that went into this ground intake. So day 2, right after kickoff, we went to our practice field and we ran some match simulations, because as soon as we saw that the source zone was not protected, we kind of figured that the GDC was going for a defense-heavy game. We wanted to confirm that and see that how much defense would matter. And in our match simulations, we really noticed that defense would make a big difference at the source if you only had a source pickup. And we decided that we would want a ground intake of some sorts, because we also noticed that the human player could really launch it towards the reef, meaning it's just way harder to defend that, which will be really helpful in playoffs at your early events and probably also at the higher levels. We originally started with a pretty skinny ground intake because we didn't want to deal with centering and stuff. And we kind of realized that we had a mid ground intake and a mid source pickup. We're like, this is not going to work. We did a really wide intake last year. We're super familiar with it. So we're like, we're just going to make another wide ground pickup. It's really paid off. Super helpful for cycles, super helpful in auto. If we had that little skinny ground intake, we would not be doing ground pickup in auto like we are now. And well, playoffs haven't happened yet, but we think it'll pay off big time in playoffs at this event as well.
Cool. All right, so your elevator.
Yeah, so as you can see, we have a internal belted continuous elevator, much like High Tide in 2023. We built a shockingly similar elevator during our 2024 off season. We made a second robot that was basically just because we needed experience with elevators. So we built basically this elevator, internal continuous belted elevator. But we took a lot of the problems that one had and solved them with this one. So we have basically two mechanisms that feels like deja vu, like we've already built them before. Since it's elevator, we built it in the off season. This intake is very similar to the one we had on our in-season robot last year. So we knew a lot of the intricacies with those types of systems, and it helped us build really consistent and robust versions of those systems, which has helped us just work every match, cycle coral every match, get the RP, get those wins.
So there's two parts to this that we invest a lot of effort in. And the first part was designing a way to control the elevator and the arm in a safe way. So the way our arm works, it extends outside of the frame perimeter to score, obviously. So we wanted to make sure it would never hit the reef, and we also wanted to make sure it wouldn't hit the belly pan. Because in the starting position, the elevator's all the way down. Of course, that means it has the physical capability to hit electronics and break stuff. So what we did is we run motion magic on the PIDs, on the PID side, on the Krakens, and then our main goal is to figure out what actual position do we need the arm to be in. So the arm can extend out both sides. So at the start of the match, it rotates like that, and then from there, it can rotate 360 degrees in either direction. It has even more physical capabilities, but we limit it to that. And to choose a safe set point, we actually have a few steps. The first step is mirror the angle so that it's whichever side is closer to the reef. That way we're actually scoring towards the reef. And then we limit it so that because it can rotate out the right or the left, we limit it so that it doesn't go like all the way back down 360 degrees away from the starting position. So the operating range is like 270 to negative 270. Okay. And then, and then in general, we always prefer to rotate away from the reef. So we use pose estimation, our relative position to the reef, to figure out which side's closer. And we will always prefer to rotate like that from the starting position. And then we apply reef safeties. So if we're close enough to the reef, as a final safety, if our current position and our set point traverse through the reef, then we just clamp it to a safe position inside the reef. And then as the last step, we clamp it so that it will never hit the belly pan, depending on the elevator height.
Could we demonstrate some of that movement?
Yeah, I would love to. So at the very start, oh yeah.
Once the match starts or the operator presses the intake button, the elevator will extend up like that. And the arm is actually faster than our elevator, so the arm will wait until the elevator's up. So if you see in the motion, the elevator there actually waits for the arm to move first, but the arm waits for the elevator when it goes back up. So they wait for each other to be at safe positions. We just have like an interpolation table running that has things mapped out from CAD. And then that helps us with that part. In addition to that, we also have 4 cameras on this robot. We have 4 OV9281s, and they're running on 2 different orange pies towards the front of our robot. And those give us full field pose estimation, and we use that for our scoring. We just have a bunch of nodes for each side of the robot, and we weigh what node will be locked onto based on the rotation and translation distance, and they're both weighted to help with that. In addition to that, the auto align is fully automated by the driver letting go of the sticks once we're close to the position. So the driver drives up, waits. If it looks lined up, they'll press the score button and it'll score. Yeah, so we can show the intake.
Yeah. Let's see an intake of coral.
Talking more about the safe machine for this year, since we have a complicated handoff and a complicated scoring mechanism, so we went with a monolithic state machine. Every single state includes a set point for all of the subsystems, aka the intake, the elevator, the arm, and all of the rollers. They're controlled in one monolithic state. And then we defined a long list of transitions that explicitly specifies under what conditions will we go from state A to state B. That way, in our code, it's very predictable. We always know what's going to happen, and it makes it's a lot more controllable that way.
Awesome. Well, thank you, Simon, Eli, Apollo. I wish you great luck in your competitions and in playoffs. Thank you for the interview.
Thank you.